Welcome back, mathematicians. In this video, we are going to find the domain of functions. The domain of a function is the set of all allowable inputs of the function. And by allowable inputs, what we mean are that the function accepts the values. So our goal is to find out what values does our function accept. Now, sometimes it's easier to think in terms of what values our function does not accept. So for example, we have f of x is equal to the expression 5x divided by the expression x squared minus 9. What we know here is because of the fraction and the fact that we have a variable in the denominator of a fraction, after we square the value and subtract 9, this cannot be equal to 0 because we cannot divide by 0. So what we do is we set that denominator x squared minus 9 equal to 0, and we solve. By solving this, it allows us to know what values, when you square that value and subtract 9, will equal 0, and those values are not part of our domain. Now there's a couple ways you could solve this equation. One of the ways is to factor. So I know that the factors of x squared minus 9 are x plus 3 and x minus 3. What I'm doing here is solving a quadratic equation. My two solutions using the zero product property are x equals negative 3 and positive 3. So as a result, I know that negative 3 and positive 3 will cause my denominator, when simplified, to be the value of 0. So I know that these two values, negative 3 and positive 3, cannot be part of my domain. Now there are two ways that you can write out the domain. The first way is in set notation. So you start with a brace and you define the variable, in this case x, because that's our input variable for our domain. You make a vertical line segment, which means such that, and then we're defining what x is or what x is not. What we know is that x cannot be equal to negative 3 or positive 3. It can be any other real number, but just not those two particular values. And so once we've defined what x is or x is not, we close the brace. That is set notation. The other notation that you might use is interval notation. Interval notation only defines what the values, what the variable, the input variable in this case, is allowed to be. So the input variable is allowed to be any real number up to the lowest value, which is negative 3. Now we can't include negative 3, which is why we put a parenthesis there, but we don't stop at negative 3. We're actually going to pick up with negative 3 and go to positive 3. And then we stop there because we cannot be equal to positive 3, so we put a parenthesis there, then a union, and then we pick up with positive 3 and go to infinity. This is meaning the same exact thing, that really our domain is a set of all real numbers except for 3 and negative 3. Those are just two different ways to write the domain. Now we go to our second function, where we have f of x is equal to the square root of 2x minus 5. Now what we know is that we cannot take the square root of a negative number. That would result in an imaginary number or a complex number. So what we know is that that expression 2x minus 5 must be greater than or equal to 0. If it's less than 0, then again what we have is a complex number. We solve this inequality by adding 5 to both sides, so we have 2x is greater than or equal to 5, and then dividing by 2, so we have x is greater than or equal to 5 halves. So we have defined x to be a value that is either equal to 5 halves or greater than 5 halves, but it cannot be less than 5 halves. In set notation, it would look like this. We're going to open a brace, define x such that x is greater than or equal to 5 halves. So by saying x is greater than or equal to 5 halves, you're defining what x is allowed to be. And in interval notation, this would be 5 halves as your boundary, and we can equal 5 halves, therefore we're going to put a bracket around 5 halves. And what we know is that can be any value greater than 5 halves, so it's going to go up to infinity. And then we put a parenthesis around infinity because infinity is not a number, it's an idea, so infinity means it never ever stops. We're going to keep going and there's always a larger value. But we know, again, it cannot be less than 5 halves, which is why we don't have any value in our interval notation that is smaller than 5 halves. All right, guys, I hope this helps. Good luck.